Imagine standing on the edge of a vast, steaming plain in what is now Idaho, millions of years ago. Suddenly, the ground heaves, and a colossal plume of ash and rock blasts into the sky, taller than Mount Everest and wide enough to blanket half the continent in choking darkness. This wasn't some Hollywood disaster flick. It was the raw power of Earth's ancient fury, reshaping the American West long before Yellowstone earned its supervolcano crown. Hey everyone, welcome back to the channel where we dive into the wild wonders of our planet. Today we're talking about Yellowstone's ancient eruptions, but not the ones you might think of first. Forget the headlines about the big bad caldera that's been dozing for 640,000 years. We're going way back beyond that famous supervolcano bowl to uncover the hidden history of a fiery trail that started over 17 million years ago. Picture this like a cosmic conveyor belt. A hotspot deep in the Earth's mantle, fixed in place, while our continent slowly slides over it like a tectonic treadmill. That slow grind sparked a chain of massive eruptions that sculpted the landscape from Nevada to Wyoming. Stick with me, because this story is like uncovering a prehistoric treasure map, full of explosive secrets that explain why Yellowstone is just the latest chapter. Let's start at the beginning. Or at least the beginning of this volcanic saga. About 17 million years ago, during what's called the Miocene epoch, the Yellowstone hotspot first punched through the crust in what's now northern Nevada and southern Oregon. No gentle bubbling here. It kicked off with fierce, rhyolitic eruptions, the kind that spew superheated silica-rich magma like a pressure cooker exploding. The first big player was the McDermott caldera, forming around 16.4 million years ago. This wasn't a tidy little volcano. It was a monster, about 28 miles across, where the ground collapsed after blasting out hundreds of cubic kilometers of ash and lava. To put that in perspective, if you stacked all the ash from McDermott, it could bury the entire state of California under 10 feet of rock. Fun fact. This caldera straddles the Nevada-Oregon border today, and parts of it are so remote that scientists only fully mapped it in the last decade using satellite tech and ground surveys. As the North American plate kept drifting southwest at about the speed your fingernails grow, roughly an inch per year, the hotspot's fire moved northeast relative to the surface. That shift lit up a 500-mile-long trail of destruction and creation, dotted with over 100 calderas. Think of it like a string of firecrackers going off one after another, each one bigger and more dramatic than the last. By around 15 million years ago, the action heated up in the Owyhee-Humboldt region of Idaho and Nevada. Eruptions there dumped layers of tough, that's hardened volcanic ash, thicker than a football field is long in some spots. These weren't just puffs of smoke. They were cataclysmic events that choked rivers with debris, creating temporary lakes that fossilized ancient forests and critters. Imagine hiking through petrified trees today, knowing they were flash frozen by a pyroclastic flow hotter than a blast furnace. Fast forward a few million years, and we hit the heart of the Snake River Plain in southern Idaho, around 12 to 10 million years ago. This is where the Bruneau-Jarbidge caldera complex stole the show. One eruption alone, about 12.8 million years ago, hurled out over 1,200 cubic kilometers of material, enough to fill the Grand Canyon 50 times over. The ash cloud from that beast traveled thousands of miles, dusting the Atlantic seaboard and even reaching the East Coast in thin layers that geologists still dig up today. It's mind-blowing. While early mammals were scurrying around what would become the U.S., this eruption was busy rewriting the map. The fallout fertilized soils in weird ways, leading to bizarre ecosystems. For instance, some of those ash layers are so nutrient-rich that they support unique plant life even now, like the wildflowers that bloom in Idaho's high deserts after a rain. But here's where it gets really intriguing. These ancient blasts weren't random chaos. They followed a pattern, building curiosity about how Earth ticks. Each caldera formed when a magma chamber emptied in a supereruption, causing the roof to collapse like a sinkhole on steroids. Then quieter phases followed. Lava flows oozed out, filling the craters and creating plateaus that look deceptively peaceful today. Take the Picabo volcanic field, erupting around 10 million years ago in central Idaho. It wasn't one big bang, but a series of them, producing massive ignimbrites, welded ash flows that cooled into cliffs you can climb. Analogies help here. Picture pouring concrete from a helicopter over a city block. That's how these flows blanketed the land, smoothing out the rugged terrain into the broad plain we drive across on I-15 today. As we trace this hotspot highway northeast, the eruptions grow more intense, setting the stage for Yellowstone's drama. Around 8 to 6 million years ago, the Hotspot volcanic field in eastern Idaho cranked things up. One key event, the Kilgore caldera eruption about 4.5 million years ago, spewed 1,000 cubic kilometers of tuff, rivaling the later Yellowstone supereruptions in scale. Ash from Kilgore blanketed much of the Midwest, and you can find its fingerprints in Nebraska quarries where it's mined for road base. Fun fact, this tuff is so fine-grained that it was used by Native American tribes for arrowheads, a subtle nod to how these ancient forces still touch our daily lives. These events reshaped rivers, like the Snake River, carving canyons deeper than the ones in Utah's Red Rock Country. Now, let's zoom in on why these older eruptions matter beyond just cool geology trivia. They reveal that Yellowstone isn't a lone wolf supervolcano. It's the current hotspot in a long line of fiery siblings. Before the famous 3 super-eruptions that formed the Huckleberry Ridge, Mesa Falls, and Lava Creek calderas, all within the last 2 million years, the ground was already primed by millions of years of buildup. For example, the Island Park caldera from 1.3 million years ago overlaps with today's Yellowstone area, but its roots trace back to those Idaho blasts. This chain reaction shows how plate tectonics and mantle plumes team up to drive continental change. Without those ancient precursors, the geysers, hot springs, and bison-filled meadows of Yellowstone National Park might not exist. Diving deeper, consider the environmental punch of these events. A super-eruption, like the one at Twin Falls caldera, 8.7 million years ago, released so much sulfur dioxide that it likely triggered a mini ice age, cooling the planet by a degree or two for years. That's like the effect of 100 Pinatubo eruptions stacked together. Life adapted, though. Fossils from these times show resilient species, from early horses to saber-toothed cats navigating ash-choked worlds. It's a reminder that Earth's history is full of resets, but nature bounces back stronger. And get this, some of that ancient magma even influenced ore deposits, leading to gold and silver mines in the region that fueled the Old West boom. As the hotspot neared its current spot under Yellowstone around 2 million years ago, the eruptions hit their peak fury. The Huckleberry Ridge tuff at 2.1 million years ago was the granddaddy, ejecting 2,500 cubic kilometers of material and forming a caldera 50 miles wide, bigger than Rhode Island. Ash layers from this are up to 1,000 feet thick in places, preserving footprints of long-extinct animals like camels and oreodonts, weird pig-like herbivores. But even this pales against the sheer longevity of the hotspot's activity. Over 17 million years, it's produced enough volume to fill Lake Superior twice, all while the continent hitched along. What ties all this together is the hotspot's deep origin. Scientists think it's a plume of superhot rock rising from near the Earth's core, about 1,800 to 800 miles down. As it melts the overriding crust, boom, volcanoes. Recent studies, including seismic imaging, show the plume is tilting a bit, maybe waning, which could explain why eruptions have spaced out over time. But don't worry, folks, the odds of a big one tomorrow are slimmer than winning the lottery. Instead, Yellowstone's current show is the hydrothermal features. Old Faithful isn't just a geyser, it's a window into those ancient forces still bubbling below. So, as we wrap up this journey through time, think about the quiet power beneath our feet. From the dusty calderas of Nevada to the steaming vents of Wyoming, Yellowstone's ancient eruptions remind us that our planet is alive, restless, and full of stories waiting to be told. Next time you're road tripping through the West, look at those vast plains and layered cliffs. They're scars from Earth's epic past, whispering of cycles that continue today. What ancient secret will you uncover on your next adventure? Hit that like button if this blew your mind, subscribe for more geological thrills, and I'll see you in the next video. Stay curious.